Hello students, welcome back to physics class. This video is continuation of motion part 7. Make sure that you have watched all the videos till part 6 before going ahead with this video. Students, are you ready for the class? So get ready for the class with your running notes. First thing is recap from last class, means what we have discussed on last class. So we have discussed acceleration, meaning of acceleration and SI unit of acceleration. Now can you recall the meaning of acceleration? Acceleration means change in velocity with respect to time. Means any object changes its velocity, means we can say that the object has some acceleration, means it is accelerated. Instead of saying change in velocity, you can say that object is accelerated. Is it clear? Acceleration means change in velocity with respect to time. Okay, so what is the SI unit of acceleration? So unit of acceleration is meter per second square. So meter per second square is a SI unit of acceleration. Okay, so now while changing the velocity of an object, it changes in a different way, right? So it may increase the velocity, it may decrease the velocity, and velocity may constant. So depending on change in velocity, we have three types of acceleration. So first one is positive acceleration, negative acceleration, and zero acceleration. Positive acceleration means increase in velocity, negative acceleration means decrease in velocity, and zero acceleration means there is no change in velocity. Okay, so velocity is constant. Velocity is constant means object should be move in uniform motion. Already you know the meaning of uniform motion. Okay, next is a graphical representation of acceleration. So last class we have discussed graphical representation of this positive acceleration, negative acceleration, and zero acceleration. The next one we have discussed is uniform and non-uniform acceleration. So what is uniform acceleration? An object changes equal change in velocity in equal interval of time is known as uniform acceleration. An object has unequal change in velocity in equal interval of time is non-uniform acceleration. Okay, the next one is uniform and non-uniform speed and velocity. Uniform speed means equal change in distance in equal interval of time is uniform speed. Non-uniform speed means unequal change in distance in equal interval of time is non-uniform speed. Okay, and same as velocity, instead of distance you can say that displacement. Okay, I hope you understood that last class what we have done. So today's topics to be covered. So today we have to discuss graphical representation of motion, means how to represent these kind of motion like uniform motion and non-uniform motion, uniform acceleration, non-uniform acceleration. So how to represent on a graph sheet. So after you have learned about graph. So in graphical representation of motion, first one will get distance time graph. So in distance time graph, we have to learn uniform as well as non-uniform motion. So uniform motion as well as non-uniform motion. Second graph is velocity time graph. Short form we can call it as a VT graph, velocity and time graph. So by using velocity and time, we have to plot a graph. So velocity time graph for uniform and non-uniform motion. And after graphical representation we need to discuss equation of motion. We have three equation of motion, we need to discuss about that, and after that we have to solve few sums on acceleration. So these are the topics today we are going to discuss. So the next one, first topic is graphical representation of motion. Okay, so we have to represent all uniform and non-uniform motion in a graph sheet. So first one is distance time graph. Distance time graph, short form you can call it as a DT graph also. Distance time graph. First is distance time graph for uniform motion. So after that we'll discuss distance time graph for non-uniform motion. So uniform motion is nothing but uniform speed. Already you know that. So this is a distance time graph. See here, we have two axes, x-axis and y-axis. Already you have learned this basic about graph, which one is x-axis, which one is y-axis. You have learned in 8th grade. In maths you have learned. Okay, once again I'm going to explain here. The horizontal line, so horizontal line of the graph we can call it as a x-axis, and the vertical line we can call it as a y-axis. Okay, so x and y-axis you know no. So in x-axis we have to mention time, and y-axis we have to mention distance. So why we have to mention time in x-axis and distance in y-axis means, because in all the graph in physics, x-axis is always independent quantity. So we have to mention only independent quantity on x-axis. In y-axis we have to mention on dependent quantity. What is the meaning of dependent quantity and independent quantity? So the name itself says that dependent quantity means the quantity should depends on other quantity, that is a dependent quantity. Independent quantity means the quantity which does not depends on any other quantity. For example, here the same graph itself, time we have mentioned on x-axis and distance we have mentioned on y-axis. Why we have mentioned time on x-axis means because time is independent quantity. Time does not depends on any other quantity at all. But distance is dependent. Distance is depends on time. Is it clear? So that's the reason distance we have mentioned on y-axis. Is it clear, children? So now, obviously, see here, distance is depends on time. So more the time, more the distance can cover, right? Is it right? So distance is depends on time. Time does not depends on distance. Is it clear? So last year you have learned how to plot a graph, means like x coordinate and y coordinate you have learned last year. So how to mention a point on graph sheet you have learned. So here I have given a table, time and distance. Okay, so time changing 10 0 10 20 30 40 50 60 second, and distance is 0 15 30 40 60 75 and 90. Okay, so now here an object covers equal distance in equal interval of time. See here, time as well as distance has equal interval. So what is the first use of this distance time graph? So by using this distance time graph we can find out a speed of an object. So how to find out speed of an object? Because we know distance and we know time, we can calculate speed of an object. Here I have calculated speed is equal to 15 divided by time. So 15 is a distance and 10 second is a time taken. So answer we got 1.5 meter per second. So 1.5 meter per second is a speed. The next one also, the next two values I have taken next itself. Distance is 30 meter and time is 20 second. So after simplification 0 0 get cancelled, 3 by 2 means 1.5 meter per second. What it shows that? It shows velocity is constant. So velocity or speed is constant. Speed is constant is nothing but uniform motion. So this graph shows that uniform motion. So what are the features of this graph? So already I told you in this graph, time is taken along x-axis and distance is taken along y-axis. Okay, and we can use distance time graph to determine speed of an object. The next one, so what is the nature of this graph? The nature of graph shows distance changes by equal amount in equal interval of time. Is it correct? This is uniform motion only. Distance is changing equal amount in equal interval of time. Okay, so distance is 15 30 45 60 15 15 difference is there. You can see that the distance is interval difference between distance is 15 15. What about time? 10 second 20 second 30 second 10 10 is a equal interval. Is it clear? So now this graph means this graph shows that uniform motion because an object covering equal distance and equal interval of time. Okay, next. Thus, for all uniform motion, the distance time graph is straight line. One thing you should remember, in uniform motion, distance time graph shows straight line only. You can able to see the straight line, right? That straight line shows that object moving in uniform motion or constant speed. I hope you clear this graph. Okay, so next graph we'll go for next one. Uniform motion is over. Next is for non-uniform motion. Same distance time graph for non-uniform motion. See, this is the distance time graph for non-uniform motion. So already speed also we have calculated in third, what is the third column, we have calculated speed also. You can see that speed. So unequal distance in equal interval of time, you know that that is a non-uniform motion. And this graph shows the curved line. So the line is curved, right? This is not a straight line. Straight line means uniform motion. This curved line shows that this is a non-uniform motion. Okay. So you know that object covers unequal distance in equal interval of time. So it moves with different speed. Different speed is nothing but non-uniform motion. You can see that distance covered also different, and time is same here. Time is 10, 20, 30, but distance covered is different. See 0, 5, 15, 30, 50, 75, 105. Here distance covered is different, even speed also different. So this is a non-uniform motion, distance time graph for non-uniform motion. See now, the nature of this graph shows that non-linear variation of distance by the object with time. Obviously, non-linear means it is not a linear variation. Non-linear means it's a different variation of distance with respect to time. Thus, the distance time graph shows curved line. The line is curved. This is not a straight line. Okay, this is about distance time graph for non-uniform motion. Is it clear? Next, one more possibility also there. So this distance time graph, if in case the line is parallel to x-axis, see this graph, you can see that the line is parallel to x-axis. See the time is 10, 20, 30, 40, 50, 60 seconds, but distance is constant. Distance is 5 meter only. So after 60 minutes also distance is 5 meter. So how to draw this graph? You can able to see this graph, right? So distance time graph, the graph will become, the line is parallel to x-axis. You know the meaning of parallel and perpendicular. Okay, the line is parallel to x-axis and perpendicular to y-axis. What it shows that, can you able to see, distance is constant. Distance is constant means we can say that there is no any movement of the object. Here car is moving, right, in a distance 5 meter. So car is in the rest position. We can say that is a rest position, right? So this graph shows that object is at rest. Okay, in distance time graph, the line is parallel to x-axis, shows that object is at rest because there is no change in distance. There is no change in distance at all. Okay, this question is there in your textbook. So what it indicates, the line is parallel to x-axis in distance time graph. What it indicates? It indicates object is at rest because there is no change in distance. Okay, so this question is there in your exercise question. Afterwards I will give the notes. Okay, so this you understood. The line is parallel to x-axis in distance time graph means object is at rest. Is it clear? So this is about distance time graph. So till now we have discussed about distance time graph. So in three possible ways we have discussed distance time graph. First one is distance time graph for uniform motion. Second one is distance time graph for non-uniform motion, and distance time graph for a line parallel to x-axis. Is it clear? So next we'll move on to velocity time graph. This is one more graph, velocity time graph. Velocity time graph means velocity should be mentioned on y-axis and time should be mentioned on x-axis. The same way, same as distance time graph. Okay, so why? Because velocity depends on time. Time does not depend on velocity. Is it clear? See now, velocity time graph for uniform acceleration. Obviously, one more thing you should remember. Distance time graph gives speed of an object. We can calculate speed of an object. In velocity time graph, we can calculate what we can calculate? Acceleration of an object. Okay, so velocity time graph for uniform acceleration. The next one is velocity time graph for non-uniform acceleration. Okay, look here, this is a graph, time and velocity. So I have given here. First point, in this graph, time is taken along x-axis and velocity is taken along y-axis. Is it correct? So velocity we have mentioned on y-axis and time we have mentioned on x-axis. That's the first point. The next one is, so by using this velocity time graph, what we can measure? So we can use velocity time graph to determine acceleration and distance covered by an object. Is it right? So by using velocity time graph, we can measure acceleration of an object and we can measure distance covered by an object. I will explain. So how to measure distance covered by an object. Okay. So acceleration and distance we can measure. See here, the nature of graph shows that velocity changes by equal amount in equal interval of time. Is it correct? Look here, in table you can see that time is equal amount changing 10, 10, 10, 10 and velocity also 15, 30, 45, 60, 75 and 90. Same 15, 15 difference is there. Is it right? So velocity is changing equal in amount and time also equal in amount. So this we can call it as uniform acceleration, right? Already you know that the meaning of uniform acceleration. Equal change in velocity in equal interval of time. Okay. So then same way in distance time graph also uniform motion shows straight line. In velocity time graph also uniform acceleration shows a straight line. Thus for all uniform accelerated motion velocity time graph is a straight line. So you understood? Uniform motion and uniform acceleration means in velocity time graph it shows a straight line, always straight line. You can see the straight line over here. So the next point is, so I told you what is the uses of this graph. We can find out acceleration as well as distance covered. Look here, the area enclosed by the velocity time graph and time axis is equal to magnitude of displacement. Magnitude of displacement is nothing but amount of displacement or distance covered by the object. So why this velocity time graph, the velocity time graph time axis is equal to magnitude of displacement means, so how to find out displacement? Displacement is equal to velocity into time, right? Why? Velocity is equal to displacement by time. So if you want to measure displacement, we need to change the formula, right? So that is velocity into time. Here velocity into time is nothing but displacement. So if you find out the area of that, area of time axis as well as the graph, you will get distance covered by the object. I have given, or area occupied by velocity time graph gives distance covered by the object. This is very important. You have to remember this. Okay. So if you calculate area in velocity time graph means you are going to calculate distance covered by the object. Okay. So we can measure distance covered by the object by measuring the area, in velocity time graph. We can measure area in velocity time graph. So I will explain later how to measure distance in velocity time graph. So we are going to solve a problem. So while explaining that, I am going to explain how to measure distance covered by an object in velocity time graph. Is it clear? So first point is, what is the first point in velocity time graph? So what is the use of velocity time graph? We can measure acceleration. Second one is we can measure distance covered by the object. Okay. And second one is in velocity time graph, if in case object moving in uniform acceleration means object has uniform acceleration means it shows that straight line, not curved line, straight line. And the third one is if we measure area in velocity time graph is a distance covered by the object. Is it clear? So now uniform acceleration is over. Next one is velocity time graph for non-uniform acceleration. So same way for non-uniform motion. Obviously this is a graph here. This is a curved line. Okay. So velocity y-axis and time is in x-axis. It shows that a curved line. See here, an object changes unequal velocity in equal interval of time. Okay, unequal velocity in equal interval of time. So this graph shows that non-uniform acceleration or change in acceleration also. We can see that change in acceleration. Okay, uniform acceleration is acceleration constant acceleration. Here is a change in acceleration. Is it clear? Next, the nature of graph shows that velocity changes by unequal amount in equal interval of time, same as a non-uniform acceleration definition. So this is for all non-uniform accelerated motion, the velocity time graph is curved line. Obviously same as uniform motion. In velocity time graph, non-uniform acceleration gives a curved line, not straight line. Straight line for uniform acceleration. Is it clear? Next, last possibility we have discussed on a distance time graph. Same way, in velocity time graph, for line parallel to x-axis, if line is parallel to x-axis, okay, so this is a graph, look here. So the line is parallel to x-axis, right? What it indicate in velocity time graph? The distance time graph, we know that it indicates object is at rest. But in velocity time graph, what it indicates? Because velocity is there, right? Y-axis is mentioned on velocity. Some velocity is there. Some velocity is there means obviously object is in moving. Object is not at rest. We can't say that object is not at rest because this is velocity time graph. It has some velocity. But in distance time graph, object is at rest because there is no change in distance. But here some velocity is there. Is it right? What it indicates? So look here. What it indicates means in velocity time graph, the line parallel to x-axis indicate the object is in uniform motion. Object is in uniform motion means a constant velocity. Means there is no change in velocity. Why? Because there is no change in velocity. That is the reason this graph indicate the object is in uniform motion. Is it clear? Velocity is constant, right? There is no change in velocity at all. But time is changing. But velocity, there is no change in velocity. So there is no change in velocity means we can say that object is moving in uniform motion. Okay. So this question also there in our textbook. I will give you notes later. Okay. So in velocity time graph also we have discussed three different graphs. One is for uniform acceleration, second one is for non-uniform acceleration, and third one is the line is parallel to x-axis. Is it clear? So this is a graphical representation of motion. So types of motion we can represent in a graph. These are the ways we can mention in a graph sheet. So I hope you clear the concept of graphical representation of motion. I hope you understood the concept of graphical representation of motion. Okay. Next, we'll discuss a sum regarding this graphical representation. So here also you can understand the meaning of those uniform acceleration and non-uniform acceleration graphical representation. Okay. So here is a sum. First one. The given VT graph, I have given here VT graph. VT graph is nothing but velocity time graph. Okay. The given velocity time graph shows the motion of an object. So object is moving some direction. It is moving some direction. Here is a graph shows. So here is a graph. Okay. This graph shows that an object moving in some direction. So the graph we have drawn in velocity time graph. Answer the following. We have to answer these two questions. First one, find acceleration. So we have to find out the acceleration of an object and its type of an object and its type. So what type of acceleration is that? Whether it is positive acceleration or negative acceleration. We have to find out the acceleration and its type of an object from where to where? From first one, O to A. So O to A we have to find out acceleration, and we have to know that we have to see that which type of acceleration is that. Next one is A to B. So A to B also we have to find out acceleration and its type. B to C. B to C also we have to find out what type of acceleration is that, and we have to find out the acceleration. That is the first question. Second question, find distance covered by the object. So here object is missing, OBJ is there, object, that is a find distance covered by the object. So how to find out distance covered by the object in velocity time graph? While explaining velocity time graph, I have explained. If you find out the area, covered by the object, it gives distance covered by the object. So we need to find out area of OABC. So we have to find out area of OABC. If we find out the area of OABC, that itself is a distance covered by the object. Is it clear? So first one, what we have to do? We should find out acceleration from O to A to B, and B to C. So now we'll find out acceleration. See, first one, acceleration from O to A. So we have to find out acceleration from O to A. Formula, you know that acceleration is equal to final velocity minus initial velocity divided by time taken. Okay, so first we'll write given u means initial velocity. So initial velocity is 0 because it starts from rest. Okay, 0 is the initial velocity. What's the final velocity? Final velocity from where to where? From O to A. Final velocity from O to A is 20 meter per second. You can see in a graph in y-axis is 20, 40 meter per second, and x-axis is 10 second, 20 second, 30 second and 40 second. Is it clear? So time taken from O to A. So O to A means you see the time axis 0 to 10. How many seconds? Time is 10 seconds. So this is how we can collect the data from graph. Is it clear? So u is 0 because starting point O to A is 0, then v is 20 meter per second because at finally it reaches point A. So corresponding point A to velocity axis is a 20 meter per second. So final velocity is 20 meter per second. So now we will calculate acceleration. How to calculate acceleration? You know formula already, you know the formula. A is equal to v minus u by t. Okay. Now v final velocity is 20, initial velocity is 0 and time is 10. So 20 minus 0 divided by 10. 20 minus 0 is nothing but 20 only. So 20 divided by 10. So 20 divided by 10 is 10 ones are 10 twos are. So acceleration is 2 meter per second square. From where to where? From O to A. Is it clear? So now what type of acceleration is that? This is a positive acceleration. Therefore, it is a positive acceleration. Why it is a positive acceleration? Because velocity is increasing. Increasing from where to where? From 0 to 20 meter per second. Is it clear? Next one. We'll find out acceleration from A to B. Already you know that A to B is a, what type of acceleration is that? Zero acceleration only, because there is no change in velocity here. No, we'll find out acceleration. You will get to know that whether it is zero acceleration or positive acceleration or negative acceleration. See now, acceleration from A to B. So we have to collect data from the graph itself. Same, A to B velocity is constant. There is no change in velocity at all. So initial velocity is also 20 meter per second and final velocity also 20 meter per second. And time, you see the time axis over there, A to B, 10 second to 30 second. So 30 minus 10 is 20 seconds. So 20 second is a time taken. Okay, is it clear? Next, same formula, A is equal to v minus u by t. Substitute all the values here, initial and final velocity. 20 minus 20 divided by 20 second. So 20 minus 20 is what? 0. So anything that divide by 0 is nothing but 0 only. Already you know that. So A is equal to 0 meter per second. So acceleration is 0 here. Why acceleration is 0? Because there is no change in velocity at all. Okay, from point A to B, there is no change in velocity. Then what type of motion is that, children? This is a uniform motion. An object move from A to B is a uniform motion. Is it clear? The one more, third one, we have to find out acceleration from A to B. Acceleration from A to B, obviously velocity is decreasing, right? B to C, it is coming to rest, motion to rest. So we have to get negative acceleration here. We'll find out now. Acceleration from A to B. What they have given? Initial velocity is 20 meter per second only. At point B, I am telling that is initial velocity now. At point B, because we need to find out acceleration from point B to C. So initial velocity B. What's the corresponding B? What's the velocity? 20 meter per second only. And final velocity is 0 because see the C point C is at 0. There is no velocity at all. C corresponding y axis 0, no. So V is equal to 0. T is equal to 10 second. Is it clear? 10 second. So now we can find out acceleration. The same formula. A is equal to V minus U by T. So A is equal to 0 minus 20 divided by 10. 0 minus 20 is minus 20, not plus 20 here. 0 minus 20 is minus 20 divided by 10. 10 ones are 10 twos are, and minus sign is as it is. So A is equal to minus 2 meter per second. So that is, this indicates negative acceleration. Negative acceleration means velocity is decreasing, or we can say that acceleration and velocity are in opposite direction. Okay, object is accelerated opposite to the direction of velocity. Is it clear? What about first condition? O to A? O to A is acceleration as well as change in velocity, both are in same direction. So that's the reason that's a positive acceleration. What about B to C? It's a negative acceleration. Is it clear? Because velocity is decreasing. Next, B, we have to find out distance covered by the object. How to find out distance covered by the object? So here I have found distance covered by the object. Distance covered by the object is nothing but area of OABC occupied by velocity time graph. Is it right? So OABC area we have to find out. So how to find out that area? It's looking at trapezium. By using trapezium formula itself we can find out, or else we can make this graph. So triangle, we can make two triangles and one square we can make here. So I have written here area of triangle OAD. So here D I didn't mention. In time 10 is there, no, you can consider that is a point D, and in 30 second is there, no, that you can consider it as a point E. I didn't mention here. You imagine that that is D and E. So we have to find out this whole area, right? First is one triangle area of triangle OAD, plus we have to measure this area also. What is that? ABED. Okay, so area of square, this is looking like square only, no? You can see that velocity axis also 20, even 10 to 30, that is also 20. So all the sides are equal, so it is a square. Area of ABED plus area of triangle BCE. At last BCE, E I didn't mention here. Okay, this is how we can measure the area here. So we know the formula, area of triangle formula, half into base into height. In triangle OAD, what is the base? OD is a base. OD is a base and AD is a height. So half into OD into AD. That's about triangle. Plus, now if you go for square, square is L into L. That is a formula to calculate area of square, no? So L into L is nothing but DE into AD. D I didn't mention here. DE into AD plus, same as usual, last triangle formula, half into base into height, half into EC. EC is a base into height. Height is BE. If you substitute all the values, half into OD. OD is a 10. In time axis you can say that 0 to 10. 10 into AD. AD is 20. You see in velocity axis 0 to 20, no? So 20 plus, next, DE into AD. DE into AD is 20 into 20, because both the sides are equal, because that is square, plus half into 10 into 20 only, because EC is 10 and BE is 20 meter. Okay, so if you simplify all those things, you can cancel 2 ones are 2 5s are 2 and 10 you can cancel 1 by 2 and 10. Again here also last step also 2 ones are 2 5s are. So next step 5 into 20 plus 20 into 20 is 400 plus 5 into 20. So 5 into 20 is 100, and last step also 5 into 20 is 100. 100 plus 100 200. 200 plus 400 is 600. So 600 meter is a distance covered by the object. Is it clear, children? So this is how we can able to measure distance covered by the object. Is it clear? This is very easy. Once again you can go through this, you will get to know that. So this is uses of velocity time graph. I hope you understood this problem. So finally we came to end of this session, children. So topic to be discussed. So what we have discussed today. So first we have discussed graphical representation of motion. In graphical representation of motion we have discussed distance time graph for uniform and non-uniform motion. Next, velocity time graph for uniform and non-uniform acceleration, not uniform and non-uniform motion. Uniform and non-uniform acceleration. The last one, equation of motion, we didn't discuss. We'll discuss on next class. These two topics, equation of motion and problems on acceleration. We'll discuss on next class. Is it, children? I hope you understood all the concept, children. So have a nice day. Thank you. Have a nice day.